We discussed question 4 for A-level Pure Mathematics 3, paper 3, May or June of year 2020. We are given a curve with equation y equals e to the 2x multiplied by a trig expression sine x plus 3 cosine x. This curve has a stationary point in the interval from 0 to pi. Part A, we need to find the x coordinate of this stationary point correct to 2 decimal places. Stationary points occurs when the derivative is 0, so we need to find dy dx first. For the equation given to us, we have e to the 2x multiplied by sine x plus 3 cosine x. We need to apply the product rule in this case. We have the product of two terms here. Applying the product rule, we differentiate the first term, e to the 2x. That gives us e to the 2x times 2. You need to differentiate 2x with respect to x. And we hold sine x plus 3 cos x. After that, we need to hold e to the 2x, and then we differentiate sine x plus 3 cos x with respect to x. Derivative of sine is cos, and the derivative of cos is negative sine. We can factor e to the 2x, and then this 2 is distributed here. So we have 2 sine x plus 6 cos x, plus for this part we have cos x minus 3 sine x, which we can simplify to 7 cos x minus sine x. Stationary points occurs when dy dx is 0. Setting dy dx to 0, we have e to the 2x, 7 cos x minus sine x equals 0. Now the product of these two terms is 0, so each of them could be set to 0. But e to the 2x can never be 0. It's an exponential function. We are left with 7 cos x minus sine x equals 0. We can rewrite this as sine x equals 7 cos x. Then, dividing throughout by cos x, we have tangent x equals 7. And we can solve this for x. Look at the ratio. You have a positive ratio, and tangent is positive in the first and the third quadrant. However, x is in between 0 and pi, which is in quadrant 1 or 2. Then this quadrant 3 doesn't apply. We need to solve for x in quadrant 1, and this is given by inverse tangent of 7. Now, x is in between 0 and pi, so you need to make sure that you are in radian mode when solving this. Then x is 1.43. So the x coordinate of the stationary point is 1.43. Part B, we need to determine whether this stationary point is a maximum or a minimum. There are two ways to do that. Either we use the second derivative test, or we use the first derivative test. To apply the second derivative test, you need to differentiate dy dx with respect to x again and apply the product rule a second time. Let's not do that. We just use the first derivative test. We look at the sign of dy dx. So for this case here, we have the stationary point at 1.43. So we only need to look at the sign of dy dx to the left of 1.43 and to the right of 1.43. To the left of 1.43, we can let x to be 1.4. So we can find the value of dy dx at x equals 1.4. And then that would give us e to the 2.8. And we have 7 cos 1.4 minus sine 1.4. Use the radian mode in your calculator to get a value of 0.2 e to the 2.8. But we do not have to care about e to the 2.8. It is always positive. A positive value multiplied by 0.2, this is always positive. So to the left of 1.43, we have a positive sign. To the right of 1.43, we could use a value of 1.5. So we have e to the 3, 7 cos 1.5 minus sine 1.5. Again, use the radian mode in your calculator. We should get a value of negative 0.5 e to the 3. And this is clearly negative since e to the 3 is positive. For this case here, we have a positive sign and a negative sign. If you join this, you see that you have a curve with a maximum value. Therefore, the stationary point must be a maximum. So the stationary point is a maximum from the first derivative task.